Hello and welcome to this video on the common statistical tests in epidemiology and biostats. This video is a part of our series on epidemiology and biostats. In my previous video, I talked about the basics of hypothesis testing and types of error and power. This video, we're going to talk about common statistical tests. Now, let us get into it. So, why is statistical testing important? Well, you want to answer claims like, my drug is more effective than the standard drug that is used. How do we answer that? Just do a statistical test. Are heart disease and exercise related? We want to know the answer to questions like this. And what helps us with this association is, again, statistical testing. Ensuring results aren't just random occurrences, meaning they're not just some random association in data that we have just noticed, and this is not just by chance. This is why we need statistical testing. Is there a downtrend in smoking? Meaning if we want to see a trend in something, in a risk factor, or in a disease, or whatever is happening, we want to do statistical testing. What's the likelihood of something happening or something not happening? That is why statistical testing is important. So to understand common statistical tests, we need to understand these two things: independent variable and dependent variable. And I'm going to take an example for you to understand this. If plants get sunlight here is the independent variable, they grow in height. So what is sunlight? Sunlight is the cause, it's the input that is resulting in some sort of effect or an outcome. We previously called this exposure an outcome. So the cause or the input that is under your control, we are controlling the amount of sunlight that the plant is getting. That's the independent variable. And the dependent variable that depends on the independent variable is basically the effect or the outcome. Just remember, if plants get sunlight, they grow in height. If somebody smokes, smoking being the independent variable, they get lung cancer. That is the dependent variable. So let's take another example for this. There's a new drug called reduction. That's the name of the medication, reduction, for blood pressure management. So if you want to use reduction for systolic blood pressure management, what would be the independent and the dependent variable? Well, you can control the drug. That's the independent variable. And what's the effect or the outcome? That's the decrease or increase, let's say. The decrease in this case, because we're using this drug to decrease BP. So that's the dependent variable, the decrease in blood pressure. So qualitative variable, what's a qualitative variable? A qualitative, these are the different types of data. Qualitative variable, also sometimes called categorical data, is basically data that cannot be counted in number, data that isn't counted in numbers. What is that? For example, qualities in a boy, gender, roles, color, your position in your company, that is qualitative data that cannot be measured in numbers, that does not have a mean. What is this student? He's a smart student. What is smart? It's a quality. It's not, you can assign a number to that, but you don't get a mean for these values. That's qualitative data, categorical data. What's quantitative variables? Quantitative variables are data that is counted and has a mean. What's the example? Well, math scores. Smart student gets high math scores. Those math scores can be counted. Age can be counted. Height and weight can be counted. That's quantitative variable. Now, whenever we want to understand, whenever we want to do statistical tests, there is usually an independent variable and there's a dependent variable. That's why we make this chart. We want to know if smoking and lung cancer are related. We want to know if studying in the library or studying at home and getting better or worse scores are related. So therefore, you always have an independent variable and a dependent variable. Therefore, we make this chart, because there are different types of tests to answer each. So we have independent variable on the row side and the dependent variable on the column side. This. And now, if your independent variable is qualitative, meaning it cannot be counted in number, meaning it's like quality, colors, smart, not smart, things like that. Yes, no, that's qualitative data. Or is it quantitative? And the same goes for the columns. If your dependent variable is qualitative or quantitative. Now, we will explore all of the different types of tests that can be used if the independent variable varies by quantitative, qualitative, or if the dependent variable is quantitative or qualitative. So let's start with the first box right here. If both your if both your independent variable and dependent variable are both qualitative. So the tests that you can use are chi-square, Fisher's exact test, and logistic regression. Let us talk about chi-square test now. This is going to be the first test that we use between when the qualitative independent variable with the qualitative dependent variable. So let's talk about this. What do we do in a chi-square test? Well, we want to know the relationship between two or more categorical variables, meaning it's just a twist of words, meaning you want to know the relationship between two categorical variables, and they're both, and another way to remember two or more is that China has a large population, so it's not going to be just two people. It can be two or always more. You don't have less than two people, or you don't have only two people. You can have two or more. You can study the relationship between two or more people in a categorical test, in a chi-square test, or categorical variables. So what are the requirements for a chi-square test? You usually have a large sample size. And the number of people in each box, what do we mean by box, needs to be greater than 5. So for chi-square test, you have two or more variables, right? Categorical variables, qualitative variables, large sample size, and the number of values in each box needs to be greater than 5. What does that mean? Let's take an example for that. So our example is, does the COVID vaccination decrease the number of people getting the disease? And this is the amount of data that we have, right? So first of all, you need to understand that is all of this data qualitative? Well, whether you're vaccinated or unvaccinated is a qualitative thing. Yes or no, right? It's not measured in numbers. Either you're yes, either you're no. Whether you get flu, basically whether you get COVID or flu is basically yes or no. It's again yes or no. So both the independent variable and the dependent variable are both qualitative. They're both qualitative. This is an example of a categorical test or a chi-square test between two qualitative variables. Now, what I want you to understand, this is usually for larger sample size, and what I mean by 5 in each cell is that the value in each of these cells need to be greater than 5 for a chi-square test to work. But what if this value is less than 5? What if this value is less than 5? Like this here. Well, then you do something called a Fisher's exact test. Fisher's exact test. What's the difference between chi-square and Fisher's exact? Well, you usually have only two categorical variables, only two, not more than two, exactly two. Like the Fisher's exact, exactly two categorical variables, meaning both the independent variable and the dependent variable are both qualitative. Okay, and then you have smaller sample sizes. It's usually used for smaller sample sizes, and you should have a smaller, at least n less than 5 in at least one of the boxes, like we had in the example previously shown. So let's take an example. You're a detective checking whether eating chocolate improves passing the exams, right? And you take 10 students. That's a small number of students. So you get 4 in this one, 1 in this one, 0 and 5. And let's see if these are dependent or independent and dependent variables are both qualitative or not. So the simple answer is whether you ate chocolate or did not eat chocolate, both qualitative. Whether you passed or you failed, both qualitative, cannot be measured in numbers. You pass or you fail, you eat chocolate or you don't eat chocolate. And the relationship between this both is being studied, so that if eating chocolate has some effect on you passing the exam or not. That's the kind of statistical question that is being answered here. And that is where exactly you use a Fisher's exact test. And the third thing that can also be used to study the relationship between two categorical variables is something called logistic regression. This is a super cool test, What is it? How I define logistic regression is statistical magic. Statistical magic. It is so cool. This is so cool. Let me understand this. So what you do with logistical regression is that you predict a categorical outcome. You predict the probability of a categorical outcome happening or not. What does that mean? based on multiple variables. This can be categorical or quantitative. What does this mean? I have a lot of examples for this particular test because I want you to understand this very, very well. But what I first want you to understand is that the outcome in this case will always be a 0 or 1. Will always be a yes or no. Will always be got the disease, didn't get the disease. Got the thing, didn't get the thing. Passed the exam, failed the exam. It's always going to be a dichotomous thing. It's always going to be a dichotomous result. Always, meaning divides only into two things. Yes or no. Right? And that probability is what logistic regression gets us. So let's understand this better with the help of an example. So you want to determine the likelihood of recovery, basically recovery happening yes or no, based on age, BMI, family history, and blood glucose. Now, what I want you to understand is that age is a quantitative variable. This is a quantitative variable. BMI is a quantitative variable. Family history is a qualitative variable because either you have family history or you don't have family history of a disease. Blood glucose is a quantitative variable. Why I told you logistic regression is a very, very cool test? It's because you can predict the likelihood of an event occurring yes or no based on multiple variables, qualitative or quantitative, does not matter. Whatever kind of independent variables you have here, whatever kind of independent variables you have here, more than one, more than two, more than five, does not matter. Does not matter. You can have as many as you want, but the outcome variable needs to be categorical and always needs to be dichotomous, meaning has only yes, no. Develop the disease, does not develop. That's the probability. The probability, the likelihood is what logistic regression gets you. Let's understand this with the help of another example. Identifying people at risk for readmission. So readmission will happen yes or no. Simple, dichotomous outcome. Yes or no is what logistic regression gets you. The probability of a yes or no happening is what logistic regression gets you. And what are the independent variables? Well, you can have as many quantitative, qualitative, whatever kind of variables you want, independent. Independent variables you can have of all kinds. Doesn't matter. We'll get it done. This is pure statistical magic. This is logistic regression. Logistic regression gets you the logical answer, the yes-no answer, the pass-fail answer, the has the disease, does not have the disease answer, will develop the disease or will not develop the disease answer. Always outcome is going to be dichotomous, meaning yes-no. But the number of independent variables, you want to say, will I develop diabetes at some later point in my life? And these are the variables that I want to study. I have family history. My weight is this. My age is this. Whatever, you can do whatever. And this logistic regression will give you the probability based on those particular factors of you developing the disease. Logistic regression, logistical magic. So let's take another example. Identify whether a student will get admission into some university or not. Basically, again, yes or no. The dependent variables is a yes or no thing. It's a dichotomous thing. It's a pass-fail thing. It's a simple answer. Either this or that. Either this or that. That is going to be the logistic regression thing. The logical answer. Based on GPA. Now, GPA is a quantitative thing, right? Test scores are quantitative. Ethnicity is qualitative. Ethnicity is qualitative. So you can have as many independent variables that you want. You can have as many independent variables that you want, but doesn't matter. If you have quantitative, qualitative, whatever kind of independent variables, but the dependent variable, the outcome needs to be a yes-no kind of thing, needs to be a dichotomous thing. Branches into two, pass or fail, yes or no. So what is logistic regression? Logistic regression predicts the logical odds, meaning yes, no, probability of a yes, no happening. What will happen more? So very, very cool. We do understood between two qualitative, we have all of these tests, right? Chi-square, Fisher's exact, logistic regression. But I told you in logistic regression, your independent variable can even be quantitative. It doesn't matter. It comes in both. It comes in both. And you predict a qualitative outcome of happening or not. Logistic regression is an answer to both of these if you just have a qualitative yes-no outcome, qualitative yes-no, dependent variable. Now let us go to this box. If we want to study a quantitative outcome, meaning t-test, like t-test, ANOVA, and linear regression. Let's first talk about t-test and then we'll talk about those later. What is t-test? You must have heard about this a lot. So let's understand this with the help of an example. Does smoking lead to an increase in BMI? What is the independent and dependent variable here? Take a minute, pause the video, see if you can figure it out. So the independent variable here is this thing, smoking. And is smoking a qualitative or a quantitative variable? It's a qualitative variable. Great, it's a qualitative variable. It's a qualitative variable. Increase in BMI, is that a quantitative or a qualitative variable? It's a quantitative variable and it is the dependent variable here. This is the dependent variable here. Great. Now we have a qualitative independent variable and a quantitative dependent variable. Great. So now you make two groups, smokers and non-smokers. Again, this is a qualitative independent variable. So what does happen in t-test? You have a qualitative input, independent variable, and a quantitative outcome. Does smoking lead to an increase in your exam scores? Does smoking lead to an increase in your BMI? Both of these are quantitative outputs, but you can either smoke or you don't smoke. It's a qualitative thing, right? So what I want you to understand this is t-test is only for two groups. Either you have smokers or non-smokers, football players or cricket players, hockey players or cricket players. Only two groups. T-test is you want to compare the odds of basically two groups, in only two groups, T for two groups. So let's take another example. You want to study the effect of coffee drinking on the time of exercise of gym bros. So you want to see if you take enough coffee, whether you can increase the time of exercise in gym bros, people who go to the gym. So now in this group you have two groups, again, coffee drinkers and not coffee drinkers or tea drinkers. Let's say you have non-coffee drinkers, people who don't drink coffee, people who drink, let's say, tea or whatever. Now let us talk about the simple difference between a paired t-test and an unpaired t-test, because that is something that comes up often in your exams and it's very, very simple actually. Very, very simple. So paired t-test is always for the same group. A paired t-test is for the same group. An unpaired t-test is for two different groups. So what does that mean? What does that mean? Basically, if you want to study the effect of an intervention on one particular group, so what you do is you hire a team of players and you give them all, you calculate the amount of goals they score, right? The amount of goals they score usually. You get one team and you calculate the amount of scores. And that amount of scores is, let's say, goal in a season is like 50 goals. They score 50 goals. Now you give them some new fancy shoes. And after giving them this new shoes, you study that in the same group, after giving them new shoes, you get 60 goals. This, whether giving them new shoes improved their goal scoring or not, is where you apply paired t-test, because it's for the same group before the new shoes and then after the new shoes. So therefore, paired t-test is usually for a before-after intervention. You want to study, let's say, the effect of an exercise on the BMI of some patients. So you study their BMI before, and then you give them the exercise, and after the exercise you measure their decrease in BMI, and it's going to be the same group. What is an unpaired t-test? That is for two different interventions, or basically an experimental group and a control group, right? So you give this group some X medication and you give this group some Y medication. So unpaired for different groups, paired T only the same group. It's going to be the same group of people. So let's take an example of paired group, measuring heart rate before and after exercise. Unpaired group, measuring heart rate in some patients, right? That work out versus those who don't. So in paired group, it's going to be the same group of people. Before exercise, you measure their heart rate, and after exercise, you measure their heart rate. Unpaired is going to be different people who work out and people who don't work out. So that's the difference between unpaired and paired t-test. So, Wahab, I want to do the same test of that tea drinking and coffee drinking thing, but I want to include English tea drinkers, coffee drinkers, non-coffee drinkers, English tea drinkers, chai tea drinkers, and then again coffee tea drinkers. You want to have more than two groups. What test do you apply? Simply put, you apply the ANOVA test. When you have more than two groups and the same kind of qualitative input and quantitative outcome, three different groups, so it's going to be the same qualitative input and quantitative output. Great, but greater or equal to 3 groups, not 2 groups. T-test is only for 2 groups. T-test is only for 2 groups. Let's take an example. So the effects of 3 different types of diet. So again, this is a qualitative input. This is a qualitative input. Remember, both T-test and ANOVA have qualitative input. They have qualitative input. And a quantitative outcome, weight loss. The amount of decrease in weight is again you can measure the amount of decrease somebody has in their weight. That is a quantitative output. But the difference between ANOVA and T-test is T is for 2 people. ANOVA is for 3 or more. ANOVA is for 3 or more. So let's take the same example. If we continue that, so you have 3 different types of diet effect on weight loss: low carb diet, low fat diet, and Mediterranean diets. These are 3 different types of diet, and you want to study the effect they have on weight loss. That is the quantitative outcome. So again, our chart, we talked about all of these different types of tests. We talked about T-test, ANOVA, and then finally linear regression. So what is exactly linear regression? Let's talk about it. Let's understand it with the help of an example. But firstly, I told you logistic regression was statistical magic. Well, linear regression is statistical magic pro max. Statistical magic pro max. Why is that? So let's take the help of an example. So for both T-test, ANOVA, and linear regression, for all 3 of them, the outcome is going to be quantitative. The outcome is going to be quantitative. But for both T-test and ANOVA, the input or the independent variable was always qualitative. Well, that does not affect linear regression. You can have all kinds of factors, similar to logistic regression, where you had all kinds of factors, all number of factors. Qualitative, quantitative, doesn't matter. You can have all types of variables. You can have all types of variables. Similarly, in linear regression, you can have all types of factors. So this say factors. So this can be stress. This can be whatever. This can be their diet. This can be, let's say if they do exercise or not. This can be their BMI. All kinds of variable, qualitative or quantitative. And whatever number, that's why statistical magic, you can have all number and all kinds of variables, and you want to study the relationship between that and a quantitative outcome. That's when you do a linear regression. Similarly, you get these really broad questions like factors in a medical student study routine that changes their test scores. So this can be the amount of hours they study, which is a quantitative thing, or where they study, which is a qualitative thing, because if they study in the library, whether they study at home, whether they study in their classroom, this can be whatever. Where do they study? How do they study? What's their study method? All of the different factors, quantitative or qualitative, can be solved by linear regression. What's the only requirement of linear regression? That, like the letter N says, and the quantitative N, like there is an N in quantitative, right? So therefore linear regression has always a quantitative outcome, and whatever kind of variables you include as an independent variable or an input, that's okay. Let's take another example. So it predicts a quantitative outcome based on multiple variables. It predicts a quantitative like the letter N here, and the letter N here, a quantitative outcome based on multiple variables. Similarly, like I said, giving you another example, let's say you want to study if somebody has an increase in their BMI with, let's say, increased stress, increased food consumption, increased in the number of calories they consume, which is quantitative, right? Stress may be qualitative. And similarly, you can have all the different factors in the world as independent variable, but your dependent variable needs to be quantitative, needs to be measurable. That is linear regression. Now I know linear regression, when I was studying, I always was confused because linear and logistic regression sound very similar. So this is just me as always. I love these differentiating lines. So what's the difference between logistic regression? Logistic regression gives you the logical outcome, the dichotomous yes or no. What is with linear regression? 0 or 1. Linear regression gives you the quantitative outcome. That is simply just that. Linear regression gives you the quantitative, like the letter N is linear N. It gives you the quantitative outcome. But what's the similarity between the two? Both of them can have multiple qualitative and quantitative independent variables. Both of them can have multiple. You can study the factors, you can study all of the different factors. Both of them have quantitative plus qualitative variables as input or exposure. So let us look at our table again. So we have independent variable on the rows and dependent variable on the columns. So for a qualitative input and a qualitative output, we have chi-square, we have Fisher's exact, and we have logistic regression. Chi-square is for two or more categorical qualitative variables that are usually a large sample size, and the number of value in each cell needs to be greater than 5. Fisher's exact test is for small sample sizes between exactly two qualitative variables. Logistic regression is statistical magic. It predicts a qualitative outcome happening based on both qualitative and quantitative types of independent variables. Statistical magic. Again, T-test is for only two groups. T-test is for two groups. So two basically qualitative groups, and predicts a quantitative outcome from happening or not happening basically. And then ANOVA is the same thing but for three or more groups. And then linear regression is statistical magic pro max. It predicts again a quantitative outcome. What's a quantitative outcome? An increase in BMI, an increase in math scores, something that you can measure, based its statistical magic pro max. So based on both quantitative and qualitative variables. That's basically everything. I did not talk about this one test, which is correlation, because I think it deserves a separate video. It is a very, very simple concept, but I will make a separate video because I think this video is getting pretty long. So what's the takeaway from this lecture? So independent variable is the input, independent variable is the exposure. Dependent variable is the outcome, it's the result. Qualitative variables are something that cannot be measured, colors, quality, drug category. Quantitative variables are things that can be measured and have a mean like time, age, weight. So chi-square is between two categorical variables, large sample size, and each cell is greater than 5. Two or more. So it can be two or more variables. Let's write that down here so that you remember. It needs to be two or more categorical variables. Fisher exact test is for exactly two small sample, and you usually have at least n less than 5 in at least one of the cells. T-test for two groups predicts a quantitative outcome in two qualitative groups, smokers or non-smokers, players or non-players, coffee drinkers or chai drinkers. Two groups, continuous quantitative outcome. ANOVA, 3 or more than 3 groups, again a continuous outcome. T is for 2, ANOVA is for 3 or more than 3. Logistic regression predicts the logical yes-no outcome, predicts the logical dichotomous outcome. Linear regression predicts the quantitative outcome. Both of them have multiple variables input, meaning they can have qualitative or quantitative, and multiple. You can have hundreds of variables, does not matter. Logistical and linear regression are statistical magic. So logistic regression predicts the logical yes-no categorical 1-0 outcome. Linear regression predicts the continuous outcome. Thank you so much for watching this video. That was all, and I think that was a very interesting topic. Be the light. Thank you.